Can somebody confirm you can hear me?
We can hear you.
Thank you. Sorry for being a bit late. I had trouble logging in because, well, Canvas wasn't working right or my computer wasn't working right. I couldn't scroll down to the Zoom link to begin the Zoom meeting. I know that sounds weird, but I did have trouble logging in. Any questions before we begin? Come on. All right, I'm not hearing anything. Let me share my screen here. Oops. I seem to be having some trouble with Canvas and Zoom and a whole bunch of things this term. I'm not sure what the trouble is, but something's been changed, and I have to say it's been giving me a lot of trouble. Today is October 7th, and we should be starting Lab 3 Microscope Basics. Do you realize there's a quiz this Wednesday? Quiz 1 is covering Chapter 10, the start of Chapter 2, sorry, it's covering chapter 1, chapter 10, the start of chapter 2, and then lab 0, 1, and 2. Any questions about anything? In this quiz, you will have the scan. Oh, that's interesting. What the heck is this? I think that's something I don't want, and I don't know how to get rid of that. I got rid of it, at least for the time being. I think that's Grammarly, but I'm not sure what that was. Um, In this quiz and in future all future quizzes, you will be giving me your scan in question 1. Okay, any questions about that? You will not have an option to give me the scan before you begin the quiz. You must give me the scan during question 1 of the quiz. Meaning I've turned off the request for you to do it before the quiz. And you're going to give it to me in question 1 when I ask for it in question 1. All right. Oops. Don't need that. I think it's lab 2. Is that right? Nope, it's lab 3 we're doing. That means I need to grade lab 2. I haven't done that yet. All right. Um, I'll try and get lab 2 graded by early tomorrow because lab 2 you can get it graded 2 times, and if you don't succeed the first time by this Saturday, this coming Saturday, you can send in another uh, correction to lab 2. What does TM mean? It's the worksheet to lab 2. Lab 3, sorry. There we go. All right, lab 3, microscope basics. Read the lab module and the class textbook, chapter 3 through the end of the section on compound light microscopy before you begin the lab. And I asked you to read it earlier, so hopefully you got it done already. The learning objective, you're not physically going to be using a real microscope. However, you will have use of a, what do you call it, a digital microscope online. And upon completion of this lab module, you should be able to locate the name, the parts of the compound light microscope, along with describing their functions, be able to calculate the total magnification for each objective lens used, know the guidelines for focusing specimens with the different objectives, meaning we have 4 different objectives on at least most of our compound light microscopes. The 10x lens, excuse me, the 4x lens, also called the scanning objective, the low power objective, also called the 10x lens, the high power objective, also called the 40x lens, and then the oil immersion lens, also called the 100x lens. And I usually give them the name by the power, like 4x, the 10x, the 40x, and the 100x, because the low power and the high power tend to get some students confused because the low power objective lens is not the lowest. That's the scanning objective lens. And then the high power objective lens is not the highest. That is the oil immersion lens or the 100x lens. Any question about any of that? All right, so I'm warning you, if you use these names, you may get the low power and the high power mixed up. Another objective, be able to estimate the size of a specimen when seen at different magnification powers, and be able to understand the rules for proper microscope care. Even though you're not really going to be using a microscope in this class, we expect you to know the rules for taking care of them because you're taking um, microbiology. And then be able to define the terms associated with the microscopy, as described in this module and in the textbook. All right, you need to memorize the names and the functions of these parts of the microscope. One is the ocular lens, also called the eyepieces. And in our compound light microscopes, we have 2 ocular lenses. You could have a microscope which only has 1, but the ones we have in the lab actually have 2. I don't see the number there. Oh, there it is there too. This is the objective lenses. And on our microscopes, there are 4. There's the scanning objective lens or the 4x lens. I think that right there, which you can barely see, is the 10x lens behind the 4x lens. I don't see the 40x lens because it's behind the 100x lens. Right there, I see the bottom of a lens, but I'm not sure which one it is. And then there's the 100x lens. No, the stage clip, it holds the, excuse me, 3 is the stage. It raises and lowers. So if you have a slide on here, you put it on the stage, and then you can raise and lower it to get it in to focus. The stage clip number 4 holds the slide into place and allows you to move it on the stage using these stage controls right here. You can move the slide this way and that way, as well as this way and that way. Any question about that? And how you do it was with the stage controls 5. One of them moves the microscope this way, the other one, or that way, and the other one moves it this way and that way. And it's these 2 knobs there that do that. All right, where's number 6? There it is. Number 6 is the what is that called? Well, I'll move on to number 7. Oh, wait a minute. It looks like number 7 got moved. This number here should be over here. I'm having a hard time moving it. Let's see if I can move it now. Nope. Hmm, I can't move it. Anyways, number 7 should be there, and that is the iris diaphragm. Oh, well, can't move number 7 over here. 6 is the, ah, oh, I've got the numbers in reverse condition. 7 is the condenser, and, oh, that's right. 6 is the iris diaphragm, 7 is the condenser lens. The condenser lens changes the light coming from the lamp, makes a cone, shining it on the specimen here. It does not magnify. And 6 opens and shuts the size of the cone. So the iris diaphragm is like a shutter on a camera. You can open it and close it to allow more light to shine on the specimen. Any questions about 6 and 7? I'm sorry, I can't get that to move. I don't know what the problem is there. Let's see if I have controls here. Nope. All right. I don't know why I'm not able to get that to move, but that should be down there. And then hopefully on yours it's correct. I haven't looked at yours. 8 is the coarse focusing knob. Right here, that's the large knob there. 9 is the fine focusing knob, the little knob right there. 8 moves the stage up and down in, well, quickly in large amounts, and 9 moves the stage up and down in small gradients, a little bit at a time. Any question about that? 10 is the power and light source. So there's a switch, turn the lamp on and off. 12 is the lamp or light. And 11 is the rheostat for turning on how bright the light will be or how dim the light will be. And the person who wrote this lab is from Australia, and apparently they don't use the name rheostat for a switch like this. He's called it the light intensity dial. Either one is correct. Any question about any of that? All right. So you should know the objective lenses shown in this table here. The scanning lens has a power of 4x. You can also call it the 4x lens. Its total magnification is 10x. Excuse me, 40x. The the magnification, the total magnification is the magnification of the objective lens times the magnification of the ocular lens. And on our microscopes in the lab, all of our ocular lenses are 10x. The highest ocular lens you can have on the most expensive microscopes are 20x. We don't have any of those. The depth of field of the 4x lens is deep, meaning when you look at an object, I don't know if you can see this, you can see most of the object from the top of the object down to the bottom of the object because of the depth of view. You can see a lot of the object. With the field of view, that's how much of the slide you can see under the objective lens. And with the 4x lens, you have the largest field of view, meaning you can see the largest amount of the slide under the 4x lens. And then a comment, it's the easiest to use, the easiest lens to use. The low power, also called the 10x objective, magnification is 100x, 10 times the power of the 10x lens. The depth of field is moderate. You can see from the top of the object, maybe down to about half of the object. The field of view is also moderate. It is smaller than the 4x lens, what you're seeing under the slide. The 40x lens or the 4 high power lens, total magnification 400x. The depth of field is small. So if you're seeing the top of the object, you can only see down about so far. And the field of view is also small. So instead of seeing a large amount of the slide, you're only seeing a small amount of the slide. And then the oil immersion lens or the 100x lens, total magnification is 1,000 times, assuming you're using oil. And the depth of field is very narrow. You can see the top of the object and just a little bit down. So you're essentially seeing only one plane through the specimen when you're using the 100x lens. And the field of view is very narrow as well. So you're seeing the smallest amount of the slide, a little bit more than a pinprick. And some comments, the oil immersion is the hardest to use because it has the smallest field of view and the narrowest depth of field, meaning you have to be focused on it exactly in order to see it. And with the 4x lens being the easiest to use, you have a large depth of field, so it doesn't matter where your exact focusing is, you can see the specimen, assuming you have it in the field of view and in the depth of field. And then it's the largest field of view, so you can easily find the specimen or find the specimen the easiest with the 4x lens under the microscope when you're looking at the slide. Any question about any of that? So no, the total magnification is the power of the ocular lens by the power of the selected objective. And for all of the microscopes that we have in microbiology, as far as I know, all the microscopes at Clark College have an ocular lens of 10x. Like I said, the best microscopes, which Clark College does not have an ocular lens of 20x, and some microscopes have a ocular lens of only 4x, like I've seen some children's microscopes having only a 4x ocular lens. Any question about any of that? All right. Besides knowing that the specimen will be magnified when viewed under the microscope, meaning there's the letter E there. It is also inverted and reversed. So instead of seeing the E like this, you'll see it like that, magnified, inverted, and reversed. Any question about any of that? All right. The iris diaphragm can be opened and closed to allow more or less light through the stage. More importantly, the iris diaphragm affects the contrast of the specimen against the background of the field. And so if you want color illumination, where the specimen will show up the best under the microscope, you want to have the iris diaphragm about the same size as the field of view that you're viewing under the objective lens. That means with the 4x lens, you should have the iris diaphragm open almost all the way, not quite all the way, but almost all the way. And then you start shutting that iris diaphragm down as you go up in power, meaning the iris diaphragm for the 4x lens, if it's like this, for the 10x lens, you should shut it down. For the 40x lens, you should shut it down further. And then for the 100x lens, you should have it really small, almost a pinprick. Any question about any of that? If you do not do that, you will not get your best fuller illumination, meaning you will not see the specimen the best you can. It will not have the best contrast with the slide, and it will not have the best, what's the word I'm looking for? Mm. Best contrast and the best viewing. It's not the word I'm looking for, but I'm losing my mind as to what word I'm looking for. We'll have the best contrast and the best. Hmm. Can anyone tell me what word I'm looking for? Let me go down here and see if I can see it here.
Is it clarity?
Yeah, that's one word. There's another one I'm trying to think of.
Maybe focus.
Resolution, that's the one I'm looking for. Thank you. All right, clarity is another word, but the idea is it just will not show as good if you don't have the iris diaphragm open to the right amount. When you first use a microscope, you should use the scanning objective lens, meaning the 4X lens. Why? Because you'll be seeing the greatest amount of the slide and you'll have the ability to have the greatest depth. So wherever you focus on the specimen, you'll see the specimen because you have the greatest depth of view and you'll have the greatest field of view. So if the specimen is on the slide, you'll be most likely to see it with the 4X lens. Any question about that? And then you work your way up from the 4X lens. With the 4X lens, you use the coarse focusing adjustment knob to slowly raise the stage up until the macroscopic object comes into focus. You then, after you use the coarse adjustment knob, you use the fine focus adjustment knob to perfectly adjust the focus. Now, once you've done that, you do not want to ever use the coarse focusing knob for any higher objective because our microscopes have parafocal vision, meaning when one objective lens, oh, come on, give me a pencil here. I know I got one behind this. Oh, here's one here. When one objective lens is in place, and then you move a next higher power objective lens in place, it should be in focus. It may not be perfect focus, but it should be in focus. And that's because we have parafocal lenses where each of the lenses is focusing at the same spot. Any question about that? And so you should only, when you switch the lenses, you should only use the fine focusing knob because you'll lose the parafocal vision if you use the coarse focusing knob. If you accidentally use the coarse focusing knob, what you should do is don't try and find, when you're going up in power with the objective lenses, don't try and use the coarse focusing knob to get it in power with the lens you have in place. Go back to the 4X lens and bring the object into coarse focus with the coarse focusing knob, and then get it in fine focus with the 4X lens with the fine focusing knob, and then return to the next higher objective, which would be in this case the 10X objective. Any question about that? Why do you do it? Because it's much easier getting the objective into fine focus using the coarse focusing knob and 4X than using the coarse focusing on 10X. Because the 4X lens has a greater depth of field. Any question about any of that? So all additional focusing, once you have the specimen in focus, should only use the fine focusing when you're going up in power with the different objective lenses. So before you switch to the next higher power objective, what you should do is center the specimen in your center of the field of view. The reason is because if you have the field of view like this, and you're looking at the specimen on this area of the field of view, when you go up to the next higher powered objective, the field of view will be smaller and the specimen will no longer be in the field of view. So you move the specimen into the center of your field of view before you go up in power to the next higher objective lens. Any question about any of that? And then you use the fine focusing knob to bring the specimen into fine focus. Move the specimen to the center of your field of view again and move up to the next higher power objective. So you repeat step 9 whenever you wish to switch from one objective lens to the next higher powered objective lens. Any question about any of that? All right. With the 100x lens, there's a special procedure you need to use when using it, meaning the 100x lens, in order to get 100x magnification, you need to add oil. Otherwise, the 100x lens will not magnify any better than the 40x lens, and the 40x lens is much easier to use than the 100x lens because it has the greater depth of field than the 100x lens and a larger field of view. So to use the 100x lens, you switch the 40x lens so it's halfway out of place and halfway in place. And the 100x lens, you don't move it into place, you have it halfway out of place. And that'll allow you to put in a drop of oil. I don't have an oil dropper here, so I'm using my eraser for that. Put in a single drop of oil right over where the specimen is on the slide, meaning it would be in the center. And then move the 100x lens into position over the specimen, meaning over the slide. That should put the 100x lens into that drop of oil, meaning that's how close the 100x lens comes to the slide, that when you have that drop of oil in there, it will form a layer between the glass slide and the objective lens, the 100x objective lens. Any question about any of that? The reason for using oil is oil has the same refractive index as glass, and this will allow more light to be gathered by the lens because when the light leaves the glass of the glass slide, it will not refract and all of the oil will come straight through the slide, straight through the oil, and straight to the glass of the objective lens. If you did not have the drop of oil in there, when the light leaves the glass and enters the air, it will refract, and some of the light rays will be bent away from the lens. And then again, when the light changes from the air to the glass of the objective lens, some of those light will refract at that interface as well. And if you put oil in there, no light refracts. So all of the light goes straight through from the specimen to the objective lens, and that way you collect more light, and that will increase the clarity and the resolution of the specimen. And you have to add that oil in there to get that to happen. Any question there? Now, whenever you use oil, you must clean oil from the objective lens with lens paper, meaning the 100x lens will always get oil on it. So that lens has to be cleaned. And if you rotate the lenses around on the microscope and the 40x lens goes through the oil, the 40x lens will also pick up oil. So you should check the 40x lens to see if it has oil on it as well and remove that oil if there is oil there with the lens paper. We only touch lens paper on the objective lenses, especially the 100x and the 40x lens, because they're the ones that can pick up the oil. If you use regular paper or chem wipes or any other paper, paper has wood fibers in it, and those wood fibers will scratch and damage the lens because the objective lenses are the most expensive part of the microscope. We do not want that to happen. And if you were to use it, you'd have to use the scratched lens all term long and deal with the decrease in resolution from the scratch on the glass. Any question about any of that? All right, so to clean the lenses, you guys will only be using lens paper. It is true that we have lens cleaner, but usually in the lab, the students would tell me that their microscope needs to be cleaned and they cleaned it with lens paper and it didn't clean. And then I would go get the lens cleaner and clean it myself and then give it to the student. Any question about that? So nothing else should touch the lens, but lens paper and obviously lens cleaner if I'm cleaning it. And it is true you can use a Q-tip or what do you ever call that, a Q swab uh, on the lens as well as cloth. We don't have any cloth in the microscope for cleaning the lenses, but paper should never go on the lens. Your fingers should never go on the lens, objective lens. Any question about any of that? Or on the ocular lens as well. Your finger should never go on either of them. All right. So activities in this lab, online students will not be performing the activity with the microscope. So therefore, the table below has already been filled in for you. However, you will be expected to know the information contained in the table. And you can use the formula for obtaining that or just memorize the table, either one. So when we have a table and we're using the 4x objective lens, the total size of the field of view is 4.5 millimeters. And if you really came into a microscope lab in the microbiology class, I actually have the students measure that out using a small ruler, 4.5 millimeters. Because you guys can't do that, we're giving it to you in real life. I guess what we should do is give you the picture and have you fill in the table yourself. But 4.5 millimeters, we filled in the table. That's 4,500 micrometers, and that's the size of the field of view. For the 10x lens, the size of the field of view is 1.8 millimeters, or 1,800 micrometers. For the 40x lens, the size of the field of view is 0.45 millimeters. And that was difficult for the students to estimate that because we give them a ruler and the smallest marking on the ruler is 1 millimeter. So the students had to estimate the size of the field of view, which was less than 1 millimeter, less than actually a half of a millimeter, then for the amount of space they could see under the microscope. And that's 450 micrometers. And then the size of the field of view for the 100x lens is only 0.18 millimeters. And this one was almost impossible for the students to get correctly because nobody would choose 0.18 micrometers. But some students actually got very close to 0.2 millimeters. It's not quite correct. It's 0.18 millimeters or 180 micrometers. Any question there? You can actually figure these numbers out by using this formula here. The diameter of the field of view of the objective in, let's say, the 10x lens, the diameter of the field of view, so you take the measurement times the diameter of the field of view in the 4x lens, so that would be 4.5 millimeters, times the 4x objective, times the magnification of the scanning objective, which would be 10x. Oh, excuse me, that's 4x, so that would be 4.5 millimeters for the scanning objective, times the divided by the magnification of the objective N, which in this case would be 10x or 1.8. And that will give you the same number for the diameter of the field of view as this table. So you either have to memorize this formula and uh, one entry in the table here, the 4.5 millimeter entry, and then you can calculate out the other numbers by this table. Any question here? It's probably easier just to memorize this table. All right. Where did I lose my place here? Why is it important to know the diameter of the field of view for the different objectives? It allows you to estimate the size of the specimen you're observing. For example, if we are using the 10x lens and the specimen takes up half of the field of view, what is the size of the specimen that you're viewing under the 10x lens? Come on, somebody can answer that. We're not answering going further until somebody makes a guess.
Could you repeat the question?
We have the specimen under the microscope that you're viewing, and we're using the low power lens or the 10x lens, and the size of the specimen is 50% of the field of view, meaning the specimen takes up half of the field of view. What is the size of the specimen?
0.9 millimeters or not
900
900
micrometers. Yeah,
micro.
either one's fine. All right. Yes, that's correct because the specimen takes up half of the field of view, and the field of view is 1.8 millimeters. That means the size of the specimen is 0.9 millimeters. And that's how you can use the table to determine the size of the specimen that you're viewing. All right, activity 2. Online students will not perform this activity, but you will be doing the virtual exercise of this activity by completing the laboratory exercises at the end of this document. We expect that you will know and understand the material on the online virtual microscope as well as the material in activity 2 here. So activity 2 has you observing something under a prepared slide, going through the proper way, viewing it using the scanning lens, moving up in power to the low power, moving up in power to the high power, the 40x lens, and then moving to the 100x lens after you add the drop of oil. And then goes through the proper specimen for cleaning the lens. Remove oil from the lens using lens paper. Oops, come on, stop that. And then removing the slide, and then putting the 4x objective into place, meaning rotating it over the light. Put the slide back in the tray. You do need to remove the oil from the slide, but you can use regular paper, or what's that called? The paper towels to remove the oil from the slide. Or you can use the lens paper if you already ripped one off and cleaned the lens with it. All right, activity 3, making a wet mount. We're not going to perform this activity. You won't be tested on it. However, if you've never made a wet mount, you should go through this procedure, how you make a wet mount. There's an advantage for using a wet mount, and that is it allows you to see the specimen alive in its natural environment, such as a specimen out of pond water. You just put the pond water on the slide, cover it with a cover slip, and then start using um, the scanning lens, 4X lens, to view it. And once you have it in focus, move up to the low power lens after you move it in the center of the field of view. Then after it's in fine focus there with the low powered lens, move it to the center of your field of view, and then view it under the high power objective lens. You shouldn't use oil on a wet mount because the cover slip being on the slide adds an extra layer there. And then when you put the 100x lens down, it can actually bump into the cover slip. You don't want that to happen because you don't want to damage the 100x lens. On the cover slip, you can also break the cover slip that way too. So we don't usually use 100x lens in a wet mount. If you've never made a wet mount in your previous courses, you should read about how to make a wet mount. And then the microscope storage protocol. Online students will not be handling a real microscope, but you are expected to know how to correctly store a microscope. So prior to storing your microscope, you should lower the stage completely, remove the slide. If it needs to be cleaned, clean it, and then put it away where the slides belong. If you use oil immersion, wipe the oil from the 100x lens using lens paper and check the 40x lens to make sure it doesn't have oil on it. If it does have oil on it, you should remove the oil from the 40x lens. If you don't do that, that oil will dry and then it'll be very difficult to see through and it will be very difficult to remove. You'll have to use lens cleaner to get the oil off the lens if the oil is dried on it. And then put the 4X objective in place, meaning lock it in place so it's over where the light is. Lower the light intensity. Switch off the light, unplug the microscope, wrap the cord neatly around the base of the microscope, or some of them have a cord wrapping, what do you call them, dials or switches or knobs, and just wrap the cord around the knobs. We don't do number 7 because I don't have my students ever change the turret. And then use both hands to handle the microscope. One hand underneath the microscope to support it, one hand holding the arm of the microscope. So always hold the microscope with 2 hands. Our microscopes are pretty heavy, so most students do, but you shouldn't hold it with one hand in case you were to lose it, balance, and drop the microscope. Always have 2 hands on the microscope. And then place the microscope back in the same cupboard you got it from and put it in the same way you came out. So if this is the front of the microscope and this is the back of the microscope, put the microscope with the front facing in and the back facing out. And the back side is the side where the eyepiece lenses are. And the front side would be the opposite side of the microscope. Any question about any of that? All right, overview the terms of a microscope. You can skip the references. And then we have a video clip on the general microscope focusing. So watch that movie. and then a video on how to add oil to the microscope. So watch that video. And then practice your microscopy skills using a virtual microscope. It may be slow if you have a slow internet connection to download. Come on, let's go. I'm not getting the link to work. All right, let me get it this way. Well, that's not all of it. Manually do it that way. So this is pretty slow here. And it's downloading. Just give it time here. There it is. Still downloading. There we go. All right, there it is here. There's the microscope. There's the slide box. There's some chem wipes. There's a lens paper. So we want to hit, you can hit the guide, the learn, the explore, the test, the options. I think we want to hit explore. And the question mark tells you what to hit. So click on there and let's grab a slide. We're going to start with the plant slide, onion root cells. And when you put the specimen on the microscope for the first time, it's going to be out of focus. You need to use the coarse focusing knob to bring it in rough focus. Move it to the center of your field of view, which it probably is. Use the fine focusing knob to get it in fine focus, and then go up to the 10x focusing knob. I wonder if I have that correct, but there we go. And then only use the fine focusing knob to get it in fine focus. About right there. It looks like it's centered in the field of view. What am I looking for? I don't see anything yet, so let's go up to the 40x lens. Oh, there's a cell going through mitosis, so I'll try and move that to the center of the field of view. And get it in fine focus, which actually it looks like it's in fine focus. I don't think I need to change the focusing any. And then go up to the 100x lens. Remember, when you go to the 100x lens, you want to put the lens halfway in, the 40x lens halfway out. So you have room to add the oil. And there's the oil there. Remember, you always go to the question mark for doing that. So add a drop of oil. And then put the oil immersion lens of 100x lens in place. And then fine focus. Looks like we need to adjust the light there. And actually, you should be adjusting the light about every time you switch the lens. I'm not seeing what I was looking at earlier with the, oh, there it is there. It's best I can get for the cell with the chromosomes in it right there. Any question about any of that? All right, the procedure, if you do it, the lab worksheet, you got to look at the slide with the over here. So I remove the slide, and you're going to put it away there, and it says lens paper. That's chem wipes. That's lens paper. So you go here, it's probably going to give you an error, meaning you should only use lens paper on the lens, and you need to get the lens paper to clean the lens. So that's incorrect. So you go here to get the lens paper, rip off a piece, clean the lens, put away the slide. And for the there we go, the animal slide. To view the finish the worksheet, you got to view the, I think it's the spider leg slide under the microscope. I'm not going to focus it there, but There it is there. See how it let me put away the spider legs because we didn't put oil on the microscope, so we were able to put it away directly. All right, any question about any of that? How do I get out of here? Maybe I'll just leave it there for the time being. So let's go through the worksheet. Oh, I've got a link for practice naming the parts of the microscope. If you click on this, I think I've got them on the web page as well. Let's go here. Close that down. Guess I'll leave that for the let's go ahead and close this down. And that down. And my mail down as well. There we go. I think I've got these links in the lab here. Are we on week 3?
Yes.
Okay. All right. So these quizzes allow you to practice using or naming the parts of the microscope. And when you open this, you'll note that it opens kind of weird here. It's best to go here. I'm surprised it's even playing in the canvas. Usually it doesn't play in the canvas. And then you start the quiz here. Be careful on the links on this page so you don't download something. Like if you go here, you're going to download whatever that PDF file is. And start the quiz here. And then the question is, select the base unit of the metric system for length. Correct answer is meter. And it'll be green. Correct. Correct. Well done. I'll tell you that too. And then scroll to the next question. I'm going to answer incorrectly this time, so you'll see what'll happen. Select the base unit of the metric system for volume. You're going to say meter again. And it said incorrect. Keep trying. And so the base unit for the metric system for volume, going to say kilogram. It's also incorrect. Oh, it gave me the answer. Was that what happened? I didn't look there, so let me scroll and do that again. The base unit of the metric system for mass. Let's go incorrect and see if that... Yeah, it's giving you the correct answer there. It's gram. I thought you got a chance to do it again, but you don't. But on this, at least on this slide. Don't hit that continue button because they'll start downloading something. And just scroll down. Metric units have prefixes that represent multiples of the base. What is the prefix for 0.01? Can anyone answer that? Kilo, centi, micro,
Wouldn't
milli.
it be milli?
Sorry?
Wouldn't it be milli?
No, it's going to be centi, I think, because that's 1/100th. So centi. Milli is 1/1000th for milligram. But good guess. Thank you for guessing, by the way. All right, that's that quiz. Let's go on to one of the other quizzes. See how they work. Come on. If you click on that, I don't think it'll work. Yeah. So you need to click on it, that link up there, and then it opens it outside of Canvas. It doesn't like to run in Canvas. Start now. You might have to subscribe. Nope, you don't have to. All right, so the main reason behind the metric system was to make trading easier, construction easier, traveling easier, voting easier.
Construction.
Anyone answer this? I'm not really sure. It's either trading easier, construction easier, not traveling, not voting.
I feel like
Something's been probably
construction.
trading, huh?
Construction sounds good.
Yeah, it's one of these two, but I'm not sure. I don't know the history of the metric system. The French invented it, and I'm assuming it was for trading merchandise with another country, but let's see if that's correct. I got it right. All right. That was just a guess, but long distances are measured in meters, centimeters, kilometers. The longest would be kilometers, so I'm going to say kilometers. And let's do the next one incorrect so that we see what will happen. 5 kilograms is 5,000 grams. So 5.2 milligrams equals 5.52 grams. First is wrong, the second right. All right, 5,000 grams does equals, excuse me, 5 kilograms does equal 5,000 grams. And this is a milligram. So that would be 1,000th of a gram, which would be 3. So 1, 2, 3. I think both are correct. I want to get them wrong, so let's go both wrong to see what happens. And it says both wrong. Your response is in red, so it's incorrect. Feedback, sorry, try again. On this one, I don't see how you can do it again, but I think both are correct. Yeah, I can't do this one again. Let's start over and see what happens. Nope, it's not going to allow me to redo that one. All right, so that's how you work on this one. It looks like once you get a wrong answer, you can't make a second guess, but it'll be red if it's wrong and green if it's correct. So any question about that? Like I said, that's just some material to help you learn the parts of the microscope. And I've got 3 quizzes in week 3 lecture, actually. We will talk about in the lecture too. And you can do that in the lab if you wish as well. All right, so let's go to the worksheet. I thought I had it up here already. There we go. So the worksheet will start with the video for showing you how to focus using the microscope, how to use oil on a microscope, and then the link for the virtual microscope. And there's one link for the purpose of naming the parts of the microscope, but you can actually get 3. I think that's just one of the 3. And then answer the question 4, fill in the blanks with the correct answer. When focusing a specimen, you should always start with which objective lens. And then 4B, when using the low power, the high power, and the oil objectives, only which focusing adjustment knob should be used, the coarse focusing adjustment knob or the fine focusing adjustment knob. 4C, the type of microscope used in the lab is and there's 2 spots here. So tell me what type of a microscope you use. And you can't say something like the Zeiss microscope or the Nikon microscope. You have to say the type of a microscope. And it's 2 names. Any question about that? I think I've got that in the lab manual. And then 4D, you should carry the microscope by holding on to something with one hand and supporting the something of the microscope with the other hand. So use 2 hands to carry the microscope. And then 4E, the objectives are attached to this part of the microscope which can be rotated to click different objective lenses into place. So name the part of the microscope. For 4F, if a microscope had the ocular lens of 10x and a high-powered objective of 45x times, what will be the microscope's total magnification? So give me the name there. And you could get that just by doing AI, but you should learn to do it yourself, because if I give this question or questions similar to this on an exam, you will not be able to use AI for your exam. And then 4G, when the stage is moved left, the image moved through the ocular moves in which direction? When the stage is moved forward, the image viewed through the ocular moves in which direction? 4H, which objective lens provides the largest field of view? 4I, which objective lens has the smallest field of view? 4J, of the methods for light adjustment, which is the most important on the microscope? And there are two possible answers I will accept. The lab does say one of them is the most important, but I would agree both of them are important. That's why I'll accept two answers. 4K, how large is the field of view when using the high power objective lens? You should give your answer in millimeters or in micrometers, meaning I had a whole bunch of students tell me something like small, and that's not what I'm looking for. I want the size in micrometers or millimeters. And then 4L, how many hairs are in the animal slide when viewing the spider leg under the 100x objective lens without moving the slides from side to side? So give me the number there. And then 2, suppose you have a typical bacterial cell and it's 2 micrometers in diameter. In the circle below, which represents the field of view, when viewed with the oil immersion objective lens, state how many cells can fit across the circle under the oil immersion lens. Show your calculations in your answer for full credit. Meaning don't just give me the answer, because you can obviously go to AI and get the answer or get it from another student. Show me your calculations for full credit. Any question about any of these questions? All right, it's currently 3:39. I'll be here until 4 o'clock to help you with any questions on the worksheet or on the lab or any other question you want. But once the last student logs out, I will log out too. So if you have a question, make sure you stay online until you ask the question, or make sure you ask the question before the last student logs out, because I'll log out once the last student logs out. Any questions?
Yeah, for that last part of the lab, there's a circle drawn there. Do we need to
Uh-huh.
draw inside the circle anything?
No, you don't need to draw anything inside the circle. You just need to answer the question.
Okay.
Okay. All right. Anything else? For those of you who did not get 100% on the plagiarism quiz, I'm going to open it and I'll make an announcement about this for one more try on getting the plagiarism quiz. And those students who had trouble seeing the answer, all of you had Macintosh computers. So you need to complain to the Canvas people that Canvas is not working correctly on your computer. If enough students complain, they'll actually look into it and try and fix the problem. If I were to complain, I'm only one instructor, and they probably will not do anything if I complain. And if only one student complains, they will also not do anything. You need a whole bunch of complaints before they will do anything. And like I said, I don't know if all Macintoshes had problems, but I know that everyone who had a trouble seeing the answer They were using a Macintosh computer. You were
But
supposed to see the answer each time you took the plagiarism quiz for each attempt one time after you took the attempt. Okay? Someone have a question? All right.
something we did something wrong.
Announcement when I open that up.